Welcome you to today's event. Our sponsors for today are Innova Technologies, Equinix, Option City, and Exelor. I'd like to thank them for making this event possible. And on another note, I'd like to thank so many of you who are sitting in the audience today who helped me. Some of you are here to support me. Some of you introduced me to the people that are in my book. And I just wanted to say I couldn't have done without you, and thank you very much. My name is Stephanie Hammer, and many of you know me in my role as a marketer for Eurex, but maybe some of you don't know that I recently wrote a book called The Architects of Electronic Trading. And the book is a collection of interviews with leaders in financial technology. And each one of those interviews, I asked the leaders to comment on a particular trend in financial technology. They talk about low latency trends like the ones we're talking about today, but they also discuss more broad trends like technology and risk management and things like globalization. Writing a book is a learning process, and in this case, learning is the real goal of the book. I help decode trends in technology because I want to serve as a bridge between the business side and technologists, because I feel that if we better understand technology, then we're more receptive on the business side to its implementation. If I have one message to highlight in today's introduction, it's that technology is the foundation of everything that we do. Again and again, my tech architects really stress the fact that technology is only valuable if it's applied to solve business issues. And so many of these gentlemen will explain in a few minutes that they are applying technology to solve our most pressing issues. Technology is the bedrock of everything that we do, is why I asked my new friend Suhit Gupta to moderate this panel, and why his chapter serves as the very first chapter in my book. Suhit Gupta is former CTO of hedge fund Maverick Capital and is currently a technology consultant. During our interview, we touched on the topic of transformational technology, or how technology can help a business transform itself. After all, the power of technology to transform a business, or even a business model, is the story of our industry today. I have a great quote from Suhit, which demonstrates both his eloquence and the reason why I asked him to moderate today's panel. New developments are helping technologists to optimize business processes, which in turn boost productivity. A better foundation on the IT side enables the business side to be more creative about generating alpha. And after all, that's why we're here. On a closing note, this book was a pleasure for me to write on a number of levels. But top on my list is that I was surrounded by optimists during the process. As a general rule, technologists are optimistic about the power of technology to transform, to take us forward. And in an industry like ours that's been experiencing some significant challenges over the past years, technology and its positive outlook is really a message that deserves to be repeated. So thanks again for coming. I wanted to single out Diane Saucier, who's going to live tweet from today's event. Thank you, Diane. If anyone else decides to tweet from today's event, please use the hashtag #TechArchitects. And without further ado, I will hand it over to my friend Suhit. Thank you.
Well, welcome everyone to today's panel. Thank you, Stephanie, for the introduction. Stephanie and I met about a year ago now, and we've had a number of conversations since then. And a few months ago, when she asked me to come and host this panel, she described how she wanted to have it in a talk show style format. And so, immediately stress level goes up, and I start thinking about, okay, so, should I do something like a Jay Leno or Conan, where I start with a monologue? And I'm not very funny, so the jokes weren't working out very well. So I start thinking, do I need to do a musical number or a dance routine like Ellen? And that would seem like a very bad idea. And when running these things by my wife, she said, just stick to what you're good at, and technology was what I'm good at, so that's where we'll stay. The topic of today's panel is technology trends that matter. And as Stephanie mentioned, this was precipitated by her book. And I'd like to thank Stephanie for setting this up. Stephanie had a ton of help from Elizabeth Samuels, Letisa Manos, and Kelly Backus, so thank you to all of them for helping set it up. And I'd like to thank Robert, John, Mike, and Bernard for attending today's panel. As we think about so I have a few questions prepared today, and I wanted to actually direct the first one right back at Stephanie. When you were writing this book, one of the questions I suspect you must have struggled with was, when writing any book about technology, is it not possible that that specific technology or trend might be obsolete by the time the book is published? I'm curious how you thought about that, and then we'll turn it over to the panel and see what they thought.
Well, having worked in the industry for about 15 years, I realized that no one was going to talk to me about secret sauce, and that if they had something that was really secret, it was staying beneath the kimono, and I wasn't going to be able to write about that. I was very cognizant of the fact, and at first I kind of tackled with the issue of whether I should write a series of articles and then later compile them into the book. But then I thought about it, and the more and more I asked people, they said that even the edges that we were talking about that were related to speed had an average duration of 6 to 8 months, and so some of the technologies that we're talking about are not yet widespread, and so they still do represent value for people.
Thank you. So I'll just let you guys introduce yourselves to the audience real quick. So Robert, do you want to kick us off?
Okay, yeah, so I'm Rob Walker. I'm CTO of a small company here in Chicago called Exelor. We specialize in low latency and ultra low latency solutions for trading firms, so everything from trading algorithms to software for market data parsing and order entry, right down to FPGA for market data, and we're also working on FPGA for order execution.
I'm John Nuff. I work for Equinix. I'm based in New York City, but I'm responsible globally for financial services for Equinix. We're a data center company, so we provide co-location to about 115 exchange deployments, about 500 buy-side, sell-side companies, and 200-300 technology providers.
Great. Mike?
Mike Persico, founder and CEO of Innova Technologies, and we are an exchange-to-exchange connectivity company. So wherever there's financial industry points of interest, we seek to connect those. And I would say up until end of 2010, mid-2011, we were a fiber-based provider. We were doing that over glass in the ground. But since then, we've shifted and are overlaying our entire fiber footprint with wireless connectivity.
Bernard?
Bernard Hosman. I am responsible for a small research team at Deutsche Börse, which is the parent company of Eurex. Our analysis based on performance and functional data serves as an input for trading system design decisions. Yeah, that's.
So as you can see, we have a good mix of people that are technologists as well as have good visibility into the business side of things. So to kick off the panel, let's start with you, Bernard. I wanted to have everybody tell me what they think about the dichotomy that might exist in the technologies that we're seeing in the hedge fund space these days, whether the most innovative technologies generally apply to elite firms, the ones that can afford it, or whether it's actually applicable to anyone.
Yeah, so I think the trading industries, the algorithmic trading industry is becoming more mature. And when it becomes more mature, the leading edge or the cutting edge technologies become available to more people, right? So what was only for the elite firms, or is only for the elite firms today, might be relevant tomorrow, right? So that's my take on that.
Mike, what do you think?
Sure. So, when we talk about elite, maybe we're talking about the size of a trading company. And, the biggest trading firms are either A, consolidating, or B, looking to do things themselves, whether it be wireless or FPGA or things of that nature. And so as a service provider, you have to stop looking at the top 5 firms, and in order to grow your business, you need to offer a service set to a wider population. And the way that we've been able to accomplish that is offering smaller slices of bandwidth, offering market data over the pipes that we provide people, and even maybe a shared service where companies are banding together to utilize something that you used to sell just to one firm.
Interesting. John, I'm wondering what you see in your space?
I think, especially related to speed, I know some of this is focused on the latency, but it's really about the collection of market data, the raw feeds from exchanges, and quickly turning around an execution. And the closer you could be to the matching engine, that was everything 5 or 6 years ago. Now what we're finding is that the speed rule is essentially, that's table stakes for most firms. You've got to be quick. But I think information now is kind of the new alpha generator.
Sure.
So people are taking, overlapping information sources, news feeds. They're still taking the raw feeds from the exchanges. But I think the way they compile the data now is essentially giving them a competitive advantage over the other firms that they compete with.
I'd like to add to something that Bernard said, which I agree with, which is that often, especially in the low latency space, technology starts off in-house with the biggest guys who can bring to bear the most resources to develop stuff. And then gradually, through companies like us, for example, finds itself into the wider public domain, where, for example, we offer FPGA technology on a few markets. We've done the R&D, we're looking to monetize that. So the barrier to entry comes down as we democratize the technology to more and more market participants that perhaps wouldn't have the in-house resources or staff to go to research and build this stuff from scratch.
That makes sense. So to John and Robert, what you just said, information is important, and actually I think, Robert, this fits very well with what you've been working on recently. In my space, I hear about big data as this buzzword that is overly used. I mean, certainly with people that are looking to potentially even pad their resumes with the fact that, hey, they are all involved in big data. And I tend to think of big data as looking for possibly needles or a needle in a stack of needles, really synthesizing that information down. I'm curious what your thoughts are on whether big data is a trend to stay. Is it something that's just something hyped up right now? And how would it be used?
Okay, so first of all, I love the phrase big data. I don't know why, it just makes me feel warm and fuzzy. But yeah, I think it's a trend that's here. It's perhaps an overused term, but it's certainly here to stay. I mean, we're in a market environment now where we've got kind of historically low volatility and reasonably low volume, and yet big data is big now. Everybody's got 10 gig pipes, and it's getting bigger. And the reason for that now is proliferation from market fragmentation to more and more interrelated products like ETFs, where in the old days maybe a move of the S&P 500 future might cause a little flurry of 500 stocks moving with it. Now you've got such a complexity of interrelated products that one big move in the S&P 500 future is going to set off moves in hundreds or thousands of secondary and tertiary products. And so when volatility comes back, when volumes come back, it's going to be an interesting place to be, because you're going to see firms that have, for example, the stereotypical solution, a server with kernel bypass and a software solution for parsing market data. That may work perfectly well for 2010 to 2013, where if we get an update in an upswing in volatility, you're going to find yourself getting run over more and more and more often, because that data that's big now is going to be overwhelmingly big, and the swings are going to be overwhelmingly large. So you really need to be investing in reasonably smart technology to try and cope with that. So for example, I mean, the biggest problem we have now is that you can deliver data at 10 gig speeds. There's only a small amount of technology that can keep up with that speed. If you try and jam that up to user space and deal with it, it's going to kill you north of about 2.5 gig sustained rate. If you think about it smartly, you can filter and normalize this stuff down either on FPGA in the server, or, for example, with new switching technology with FPGA on it, you can actually do it as the data enters your cabinet, filter it down to a manageable size, and then your regular software solution with kernel bypass and your user space CPU can keep up. I think that's the smart way of solving the big data problem, rather than the the other way, which is just to chuck more money at the problem and kick the can down the road a little bit further.
Sure.
And I think, we're seeing firms look at information. They might be trading only cash equities, but it might be global. So we're seeing those firms take currency feeds as an example, and they've got a global portfolio. They're looking at the yen in relation to the euro, in relation to the US dollar.
Sure.
And so there's a lot of risk management that's being done real time, especially looking into the portfolio and trying to manage risk with a lot of these, very large data feeds.
Right. Interesting.
Well, and I find it interesting as well is that there is big data needs, but then we specialize in little data. When we first, in 1999, set up the Eurex network here in the U.S., we were using 64K circuits. That was the equivalent of a dial-up modem. That's what people were trading over, right? And then everything scaled all the way up to 10 gig, and people were looking at 40 and 100 gig. And then with the advent of wireless, now people are buying megabytes again. And people are looking at, how small can my frame sizes go? And so that's forced people to be more efficient. It's great to take the whole book, right? All level 2 data, if you can, right? But when you can't, then it forces the whole industry to reevaluate and try and be a little bit more efficient.
Interesting.
The question was, how long will this stay a topic, right?
Right.
And so whenever there's a technology shock or any shock in any industry, so there will be people well positioned and people less well positioned, and any shock will hurt for a short while. And I think we're just at the start of the shock and won't last too long, I guess. Yeah.
Okay. So question directly for you, John. The other trend that is widespread these days is cloud, for whatever that may mean. And when you talk to different technologists, each one has a slightly different view of what it actually means. But specifically from a business point of view, especially in my last stint, the common feeling among members of the business was that cloud was a panacea to either save money or to be able to push a large part of their technology out somewhere else that they didn't have to worry about it. How much of that is true? How do you think about it?
It's pretty limited use. A lot of it right now, technically cloud is internet access service, and there's very little of that. I think some of the Monte Carlo simulation type activity or use of public data sets like large tick history databases that are really public data sets can be offloaded into the cloud, but a lot of the security policies in financial institutions, as you know, don't allow you to send that data over the internet. So I think the cloud that we're seeing, a lot of it is stored or they're using servers on premise. And so it's typically across the room. So we see more hybrid utilization than pure internet-based cloud services.
Very interesting.
Clearly, for latency-sensitive trading, this wouldn't make sense at all. But from an exchange point of view, there are tons of things that we could move into the cloud. For one, we could move simulation environments into the cloud where people can test their own software before they roll it into production, right?
So, but how do you think about risk then as it relates to that?
Yeah, so for risk in the simulation environment plays virtually no role, right?
I see.
There's no.
Yeah, very good, for back testing, especially from the exchanges. I think you'll see a lot of that, where the exchanges will make their data sets public and you can do back testing, and it'll look just like production, and I think that's the key.
Yeah, great. So let's perhaps take this up one level, and another question for the entire panel. If you had to give your single best, most key piece of advice that is somewhat practical that people in the audience can actually go utilize instantaneously or implement or work towards immediately, and I'll start with you, Bernard. What would you think that would be?
So the question is whether you should implement.
We can switch subjects from cloud or big data to something else if you think. But more around what do you think is practical in terms of technology these days that people should actively look at?
So clearly FPGA technology and microwave technology are for trading firms can be key to many business models. We see lots of clients that really depend on the last 10 microseconds of latency, and if you don't adopt those technologies, that will put you out of business. However, it's very important to figure out whether you actually depend on those 10 microseconds. We see some members adopt technologies while they might not actually use it. We've got, for instance, a 10 gig offering, which would save you 60 microseconds over other participants. And then the funny thing is that sometimes it turns out that the opportunities they compete for are not contested at all. Right. So it's very important to evaluate whether you depend, if your edge depends on this.
Right.
I guess.
Interesting.
Yeah, and I would certainly echo that sentiment. Basically, what are your core competencies as a firm? And what do you need for your strategy to be successful? And then those are the things that you should focus on. And it's not the same for every company.
Right.
And so, optimize what needs the most optimization.
Mm-hmm.
If you don't get anything from 60 mics on a 10 gig, then don't buy it, right? And so it's really less a question for us and more a question for the firms to say, okay, I need to understand what's important to me, and are we good at the things that are important to us? And if you're not, then those are the things you should look to a vendor to help you with.
Right. Interesting. So both of you are echoing the make sure you invest your money wisely in specifically what it is you want to extract from that.
Right. It's very hard to, I liken it to the execution stack. You've got the algorithm, you've got the market data, you've got the network layer, and then you've got the physical path. Very few firms can optimize on all 4 layers of those. So you have to pick which one is most important to you and then optimize there.
Sure. What do you think?
Yeah, I would echo that. I think the old model, even just 5 years ago, was to outsource as much as possible to a single vendor. And the one-stop shop was the model. So you had, a full-service vendor, and if you could do that, your headaches were gone. Problem was you weren't very competitive. And today, I think that model's essentially dead. A lot of the companies coming to us right now are trying to unbundle. And instead of having one monolithic provider, they're looking for that right, market data firm. They're looking for low latency access. They're looking for optimized software or something like FPGA. And so I think Mike said it best, is each firm has a different profile based on what their trading strategy is. And you connect the dots a little bit differently. But to think you can go into someone with a turnkey solution and they can take care of 80, 90% of your headaches, you're going to be at a competitive disadvantage over time.
Robert?
I would agree. When you're targeting, when you think that you need the last 60 mics, make sure you actually need them. Because we've been approached by guys who they're attracted to FPGA, they realize all the competition's on FPGA, and sure, I can put it in, but if you're not co-located in the right place, if you've got a lossy network that you're not fully in control of, literally it's a waste of money, frankly.
Sure.
You should be targeting, you should be improving those things first.
Right.
It's not 2009 where there was money just being thrown around at anything and everything, right? It's nowadays we've got to hunker down and make sure that we're spending wisely.
Makes sense.
Plus, maybe one more thing to add is that reducing your latency by maybe 3 or 4 micros might not matter if the latency of exchange infrastructure still has a very high variance, right?
Yep.
So that's also, I think, very important.
Interesting. So, Mike, since you're highly knowledgeable about networking, do you feel there is a way individuals should, or companies should think about the technology that they invest in, whether it's a passing trend or something here to stay, whether it's the technology that you're focused on or just a broad swath? How should people think about that?
Well, the concept of exchange-to-exchange connectivity is not a passing trend. And so the medium that you accomplish that over might be, you went from copper to fiber to now wireless, and maybe we go back to fiber when we've sorted out hollow core. And I am of a firm believer that how we will see, not only in our lifetimes but probably in our careers, we will see someone deploy hollow core fiber between, if not exchanges, but maybe from a tower into an exchange. So 700 meters, maybe a kilometer, because all of the latencies are going to coalesce. And so then that 700 meters, if you can go over hollow core fiber, you then have an advantage over your competitors who are coming in over regular fiber. So trust me, wireless is not the end game.
Sure.
The mediums will change, but the concept of connecting, NASDAQ to NYSE or CME to Eurex, those will remain static.
Interesting. So pushing on this one perhaps a little bit more, do you feel like there's a particular technology that would give a firm a competitive edge if they invested in it today, or it's like I think all four of you have said, it is all about the stack, and for each firm it's a different thing they would find the sweet spot for them?
Yeah, I mean, it's somewhat redundant of the last question, in as much as that, I don't want to say someone should buy my technology if they don't need to be first in the queue.
Sure.
Right? So really, it depends. It goes back to the strategy. And, is it your strategy high frequency? I mean, we built a network, I always joke, we built the first low frequency network. And what I mean is that we put up a network between Washington, D.C. and Chicago. So that's for the news feed when the Department of Labor puts out their numbers. And you don't need high frequency for that at all. When they put out, the CPI,
Right.
you only want it once. You want it fast,
Right.
but you only want it once. So, we're not all about HFT. We're about LFT as well.
Got it. So switching gears then, since I think we've exhausted that topic. John, you, I think this is in the book as well, you coined the term trading smart. And I'm curious how you think technology for certain firms is changing the way they think about their dependency on speed versus anything else.
Yeah, I think that feeds back to the information sources and kind of the voracious appetite that we're seeing for information sources. So we say, speed doesn't make a bad trade better. It will just bankrupt you that much faster, right? So you have to be on the right side of the market. You've got to do your risk checks. So you have to trade smart, or trade smarter, but you have to trade smart quickly. And the market can move against you once you've determined where you want to execute or what you want to trade. You've essentially got to get into the market quickly. So we're seeing a lot of the investment being put into the pre-trade risk checks. I think there's going to be a lot of portfolio risk checks. Some of the larger firms that are managing multiple funds need to make sure they're not too heavy, in any one certain asset class or different industries. So that's where we're seeing a lot of investment from our customers.
I see. Robert, your thoughts on this?
Yeah, so to me, trading, so in some ways trading smart can reduce your dependency on speed. Now in HFT, for example, speed's always going to be critical, but you don't have to have an entire end-to-end FPGA trading stack. If you think about the problem a little more smartly, like as I was mentioning earlier, filter and normalize the data at your front door, deliver only what's necessary, you can get away with a traditional plant with a kernel bypass and a software implementation, and that's going to work just fine. It's all about where you choose to target your resources. If you target it at managing the data, you'll probably find that you can cope pretty well with a software solution.
That's a great point. It used to be too expensive to take a raw feed, right? On options or futures, so you took an opera feed, and now I think you can buy essentially appliance-based or logic on the card that can enable you to take those raw feeds. You can filter it, just take the portions that you need. You can get that faster, and then you don't have to execute as quickly. So that's a great point. from Robert.
But that
Great.
just depends on how long it takes for the competition to figure out that you're trading smart, right? That's, Unless
I'll happily let anybody trade smart.
So, John, since you're in the data center space, given the trading floors are making a transition into quasi data centers themselves, how do you find the data centers are evolving to keep up with that change?
Well, what we're seeing, the olden days, like they talk about in New York, the buttonwood tree is always the famous story, right? The traders used to meet under the buttonwood tree, and you had better market intelligence because you were close to the group of traders.
Sure.
And we see the same behavior now with the computers. So a lot of the intelligence is being built in to the logic, into the software stack. And now the computers from different companies and different information providers need to be assembled, not under a buttonwood tree, but redundant powered, big generator, well-cooled data centers. But it's the same thing. It's a sense of community, but now all those systems are being assembled in the same area. So in a market like Frankfurt, where we host for Xetra and Eurex, the community that's created, it kind of becomes a critical mass of information providers, buy-side, sell-side, clearing, the exchanges, the news feeds, the indices are all available very closely, so you're able to trade smarter and you're able to do it quickly because those resources are essentially across the room. So what we're seeing is where these communities develop, the exchanges are actually coming into the communities. So we've had we just had a press release today of an exchange in London that's moving into our London hub because there's a couple hundred firms that are already there. So that community of trading firms and information providers is actually becoming a magnet for exchange. Computers from different companies and different information providers need to be assembled, not under a buttonwood tree, but redundant powered, big generator, well-cooled data centers. But it's the same thing. It's a sense of community, but now all those systems are being assembled in the same area. So in a market like Frankfurt, where we host for Xetra and Eurex, the community that's created, it kind of becomes a critical mass of information providers, buy-side, sell-side, clearing, the exchanges, the news feeds, the indices are all available very closely, so you're able to trade smarter and you're able to do it quickly because those resources are essentially across the room. So what we're seeing is where these communities develop, the exchanges are actually coming into the communities. So we just had a press release today of an exchange in London that's moving into our London hub because there's a couple hundred firms that are already there. So that community of trading firms and information providers is actually becoming a magnet for exchanges. I wouldn't call them the new trading floors. Some of the exchanges still have trading floors, but they're kind of becoming the inflow and outflow point for a lot of the global exchanges.
Does that require you, from a perhaps infrastructure point of view, are you designing data centers differently to accommodate for that, or?
Yes, much bigger. The last data center we built in New York 5, is 7,000 cabinets, which is huge. Our last data center was just under 5,000, so we're having it larger and larger from a scale perspective because demand is pretty high.
Interesting. What are you seeing, Mike, on the networking side?
In terms of?
So as trading floors are perhaps more and more being pushed into the data center, do you find that the demands for networking are changing beyond just speed and redundancy? Are there other shifts that you're seeing?
Yeah, I remember when Chicago went electronic, that was the ACE Alliance, that was the impetus for that, and it was interesting because we were home running out all the connectivity back to people's headquarters. So we were building mini data centers on in their headquarters, 20-ton chillers, and wiring the entire office, and server farms, and sort of thank God that went away because it was a nightmare. A lot of these buildings didn't have the right capabilities to support that. They didn't have the power requirements. They didn't have, the fiber requirements. And so I think it's a good thing that proximity hosting has taken over and is the de facto standard. Now, selfishly, I don't want too much consolidation, right? I need to be able to connect disparate points, right?
Of course.
So, don't everybody go to Equinix. I'm just kidding.
I'd like to object to that.
We talked a few times about microwaves and FPGAs, and there's a quote that Bernard, I think you know of, latency reducing technologies like microwaves and FPGAs are making it harder for all of us to compete.
Yeah.
Defensible argument? No?
In a sense, yes. But that has always been the case, right? There's always been a hurdle to compete, but that's not unique for the trading industry, right? So the question is whether you should hold back technology investments. In the end, you should let the market decide which investment is worth it or it's not worth it, right? That's at least my take on that. Yeah.
Interesting. Mike?
It's progress. The floors gave way to the screen, to point and click on the screen. Point and click gave way to the algorithm. 1 gig, fiber circuits gave way to 10 gig circuits. And ultimately, this is about the progress of optimization. And you can't stop that, and you almost can't complain about it. Your two solutions are you can either adapt, and we don't like adapting too much because that sort of infers you're following, or you can disrupt. And disruption to us means you're the one that's actually changing things. So then, ostensibly, you could be the leader.
Sure.
So we call it progress, not a hurdle.
Interesting. John or Robert, any thoughts?
I think the technology moves on, and for every big in-house team that can build stuff, there's a small upstart that sees a market opportunity to make that technology accessible to guys that can't afford to get into it themselves, and everyone piles on, and technology moves on. Sadly, there's always going to be a big player with deeper pockets than everybody else, but that doesn't mean that everybody else has to be left by the wayside, of course, because this is the joy of capitalism. There's a space to be filled by democratizing this stuff, so someone is going to jump in and do it.
Interesting. So,
I think it's like a ratchet, right? Technology, it's better, faster, cheaper. You just keep following that cycle, and as a technologist or even as a business person, demanding things from your technologist, that's the way it goes. And if you can't reach that price performance delta, you've got to look at upstart disruptive providers.
Right.
Typically, they're not your vendor that you're already paying $10 million a year. It's going to be a company you've never heard of that you meet at the very last booth in a trade show somewhere, right? And so you've got to have a process of creative destruction in your own organization.
Right.
And that's just kind of backing up the point that Mike made. You've got to break out ahead in certain areas. But the horse and buggy days are definitely not coming back.
Right. So we've talked, again, a lot about microwaves, and so let's get into some of the deeper aspects of microwaves. Mike, again, Innova Technologies, hardcore networking equipment. How much do the physical limitations of microwaves handicap it right now?
Well, if you're in the cornfields of Ohio, not a lot, right? To go the furthest distance with a microwave dish, you're looking at a 10-foot in diameter.
Mm-hmm.
Those can weigh up to 4,000 pounds. So, again, in the cornfields, it's okay, right? But when you get into densely packed metropolitan areas, there's not a lot of space for that, and there's incredible zoning issues with it. Or if you get into residential areas, boy, people don't like looking over their shoulder at that behemoth.
Sure.
And so their footprint sometimes causes them issues when trying to be deployed in, let's call it the last mile or the short haul distances.
Got it. What are your thoughts on advantages of for microwaves in the HFT space? Is it limited mostly to HFT? I remember, for example, when I was at Maverick, and their headquarters are in the middle of New York City. It's on Fifth Avenue and 59th Street. The constant threat of terror and loss of electricity because of it, or networking because of it, is a big issue, and so it's often thought of as a potential solution for BCP or DR. So I can think of that as being a potential reason, but are there others, or is microwaves made are the advantages of microwaves mostly for the HFT space?
So, I mean, HFT is largely an early adopter of some of these technologies, but as I spoke about earlier, there are other uses for it. For example, the events trade, which is not a high-frequency trade, that's a low-frequency trade, and so it's less about the frequency and it's more about the latency. And we, as an industry, are driving latency down to zero. I mean, people call it the race to zero, but before we get to zero, we'll lose the ability to test it. Their test sets aren't granular enough to pick up, just before zero. And so, basically, that's the most important piece of microwaves is driving the latency down. Now, is there some aspect of diversity to it, such that, there's a fiber transport and there's microwave transport? Sure. But I don't think people are paying the premiums for this service to have it be diverse, right? I mean, it's meant to operate at 50% of the latencies people had heretofore experienced.
Right. Bernard, I think you wanted to.
No, yeah. So my take would be that in the news trading business, opportunities are not that abundant, right? So there's a significant but limited amount of money on the table to pay for these technologies. However, of course, they're built, but the number of players, therefore, that is able to participate in this field is quite limited so far, I would say. Yeah.
Interesting. I wonder, some microwaves also potentially suffer from a bit of an image problem as well. I don't know, I mean, is a day like today a bad day for microwaves? Is line of sight a really key thing, and therefore if you are blocked for whatever reason, I mean, is that credibility or image problem a real thing? Robert, what do you think?
I think it's a real thing. It's the classic two-pronged problem, really. Microwaves the microwave is very fast, but it suffers from a much smaller pipe than you're used to. Mike made a great point earlier. We kind of went, many trading firms went from dark fiber with potentially unlimited bandwidth, got sloppy, and suddenly now they need this unbelievable creativity to jam everything into 100 megs. You've got very thin pipes, and they're only as reliable as the weather. There's a few things you can do to try and address that. For example, if you're doing a classic Chicago, New York ARB, you probably don't need the full 9,000 total view symbols in Chicago. So filter them in Carteret, take it down to the 20 that you can reliably get down the pipe, and ship it down to Aurora wirelessly. You can, if you control the actual hardware that puts it on the line, for example, you do it in an FPGA-enabled switch, you can measure in real time the kind of bandwidth you have available at any given point. So if the Spider ETF ticks, if you've got enough bandwidth, why not stick 7 or 8 redundant copies of that tick onto that pipe with maybe a 200 mic gap between them. So if your line drops out and you miss 2, 3, 4, you've got a good chance of at least getting something there.
Right.
If you're going to do it sensibly, then you'd probably, why not send the 20 that you want by microwave, send the whole feed by spread fiber. At the other end, have an appliance, again, like an FPGA-powered switch, doing live line arbitration between fiber and spread. So you're going to get it, guaranteed. You're never going to be slower than fiber, but 95% of the time, hopefully more, you'll be considerably faster. There's a good few ways that FPGA, for example, can help you with the inherent difficulties of microwave.
I see the plug there.
the attenuation issue, right? And so certain profiles of precipitation, you lose signal. But think about in the last few months during Hurricane Sandy in New York, a lot of central offices went down. So the telecommunications networks in certain parts of New York, New Jersey were literally underwater, or the generators ran out of diesel fuel, and many firms completely lost their telecommunications infrastructure. There was no regen of dark fiber signals at the CO, so that would have been a perfect time to have microwave at the headquarters, or the small hedge fund serving that building. So I think that Mike's technology is going to get more prevalent, not just point-to-point financial points of interest, but if you think about the old WinStar infrastructure, right? I think a lot of people were wishing WinStar was still in business
Right.
6 months ago. And business-only broadband is doing, I think, a little bit of this, but I think there is a place for wireless in the day-to-day.
Although, and not to take us too far off topic, but there is something to be said about the fact that mobility is allowing traders to just work from home in case of emergencies like Hurricane Sandy.
Yeah.
And so I'm not disagreeing with you, but it gives me pause to think about being able to make a really crisp business case about the fact that the business can say, hey, it's going to cost us so much money to put a microwave dish up there and at the data center. Perhaps we can just make do with a bunch of iPads or something like that. So, hey, just my thought. So what are you, Mike, what are you seeing about, and this is purely from a geeky point of view, what do you think is coming after microwaves? I know gravity-assisted field of some kind, or I don't know.
No, I mean, listen, the wireless space still needs to mature. I mean, the reason that you have reliability issues is because we've taken a technology that's from the 1950s and adapted it for our usage, right? And you had to take it almost in the sort of how it was, as is, right? But there's lots of money being poured into this right now. So as it stands today, the networks aren't carrier grade.
Sure.
But sort of counter to that point, that I've had people tell me, I'd rather be the fastest 80% of the time, right?
Right.
So then is reliability really a concern? But let's assume for the second that it is. We see speed being equalized. We see the equipment latencies and the paths generally coming together to form a very narrow band. And so ultimately, the sophisticated firms won't make decisions based off speed. They will make decisions based off of availability. Because if you're down because of atmospheric attenuation and your competitors aren't, well, you have a real problem then. And so, in that vein, and I'll enter into the plug territory here, we have a product that combines RF with lasers. So it's called free space optics, and it's been around for some time, but their problem was they could only go a kilometer and a half. But we've got our technology to go 10 kilometers. And
Excellent.
These two live together in harmony. And what the laser doesn't like, the RF is fine with. And what RF doesn't like, the laser's fine with. And so ultimately, we end up delivering fiber through the air. I mean, our SLAs right now have no trading hour carve-outs and no weather carve-outs. We're looking at 4 nines of availability on a wireless circuit.
That's fantastic.
So to me, I'm solving for that reliability image problem here.
Or a field where we have a competitive advantage, unless we start delaying data that we would transport via those networks, so delaying all the other data and creating our own competitive advantage there, which I don't think is even legal. So that's the point is that I think we're very happy that we don't have I think we learned a lesson that how exchanges should not be in the business of transporting data from the US market structure.
Okay.
There is one spot that I think exchanges are very keen to get into, and that's putting their market data feeds over the wires, or over wireless. And you look at it, you've got the CME and NASDAQ doing a deal, and you know, you talk about democratization of this and opening it up to more people, and market data over wireless is a way to take a premium-based service and offer it to a larger percentage of the people. And I always joke with the exchanges, because we talk to them a lot about this, and I say, I used to sell bandwidth and you used to sell market data. I think we're selling the same thing now. You know, so there's got to be a level of cooperation between the network providers and the exchanges that really didn't exist before. You know, and that will give a better product set to the trading firms.
Interesting.
Okay, so can I quickly reply on that? I do understand the point, but there are two problems with that. What you're saying is that exchanges should think about providing data specifically usable for microwaves, right? But the problem is, I would say, is that the different trading participants listen to different signals and would have their own preferences about what to send and what not, right? So I don't think it's up to us to decide on what to provide for those microwave, on such a microwave feed, right?
Yeah, I mean, it's definitely a new product set, right? And you could say, okay, I'll give you top of book, and I'll give you five symbols, you know, and then people can pick those 5 symbols that they might want, and then there's your feed that you're sending out.
Or for instance, only really big trades, right? But the problem is then you would have a lot of different feeds for a lot of different participants. I think one very important thing that an exchange should always keep in mind is that different data streams should all provide the same latency, right? So you don't want to have a situation where participants should be figuring out which one of those different feeds gives the fastest information, because that creates a lot of workload for our firms or for our member firms. That is basically useless time invested, right? Yeah.
Okay, so let's talk a little bit more about FPGAs since we talked about microwaves. And Robert, since you're our resident expert, what is, so clearly microwaves are solving a different aspect of speeding up the overall execution stack. In an FPGA-centric world, where do you think that is going? What part of the stack is FPGA or the technology of FPGA going to solve next?
Okay. So the classic problem that FPGAs have solved historically is market data processing. And that's a great solution because you can really exploit the parallelizability, I don't know if that's a word, hopefully no dictionary checking.
It is now.
Of the FPGA. But where we're seeing more interest now is, for example, on the order routing side. And this is interesting. We've had an FPGA-powered switch in our lab for some time now, and we've already got it with a hardware-based TCP offload engine, logging into the NASDAQ and heartbeating all day and logging out at the end of the day. And from there, it's a really pretty short step to all kinds of applications like inline 15C3-5 risk checking, which through an FPGA switch you could actually do as you're switching onto the exchange handoff, which you've got to do anyway. Right. It also opens up other doors. For example, where I'm really seeing that we're going to be going to, in hopefully the not too distant future at all, will be offering customers, offering FPGA savvy customers, I guess, IP blocks for receiving market data in a uniform way, and IP blocks with a normalized interface for placing orders in a uniform way, and allowing those customers to glue the two together themselves, either with handwritten Verilog or VHDL, or potentially even using something like OpenCL or Impulse-C for writing that FPGA glue. So we might actually be at the point where you can go from tick to trade without even properly entering your cabinet if you do it on the switch.
Sure. And how do you feel about the relationship between FPGAs, the technology, and the programming talent that is helping put it together? I mean, is it completely directly linked, or is there more there?
It's a very good question, and at the moment, I see a lot of movements in the industry to try and break this barrier down, but at the moment, a lot of the success of FPGA projects I find to be tightly tied to the quality of the guys you've got doing it. And it's difficult because if you've got no experience of FPGA, you can't even really interview the staff, you can't even assess their quality, let alone assess the quality of their creations. So there are some movements in the industry to try and get rid of this barrier and try and somehow promote your average Joe software guy to be able to harness the power of FPGAs. Things like I mentioned OpenCL and Impulse-C. The problem often is that you really, if you want to take advantage of FPGA, you really need to be thinking differently. Because an FPGA, okay, you can get an ARM7 on a chip, it's still only going to run at a gig. It's never going to compete with a Xeon processor, which will run at 4 gigs in user space. So you take your C code, you compile it to FPGA, and look at that, it runs an order of magnitude slower than it did in user space. So you really need a talented programmer who's thinking about parallelization opportunities and hand codes, optimal code to take the best advantage of the FPGA and the other hardware machinery he has at hand. So I think the industry is trying to move in the right direction, but for a while, I'm afraid it's still going to be tied to the talent.
Interesting. Since I wanted to leave enough time for the audience to be able to ask questions, I'll move to the last question, and this is open to everyone. Bernard, we'll start with you. If you had to give, and I think we've covered aspect, advice to a startup fund, somebody who's looking to get into the space, what kind of advice would you give them? How should they either get started, or what technologies can they live without, can they not live without?
Okay, so I think, of course I already mentioned that it's important to figure out whether you actually need this latency. Another aspect is if you really depend on this edge over your competition, then it also makes sense to figure out if you should be doing this yourself or not, right? Because if your competition also has access to a service provided by somebody else, then clearly they're going to catch up with you.
Sure.
Right. So that would be my advice.
Mike?
So, my personal viewpoint on it is that, a firm starting off should focus on their human talent. Focus on your developers, focus on your quants, focus on that aspect of it, because if we truly are, as technology providers, if we truly are hurtling towards the race to zero, okay, once we get there, who makes the difference? Humans do, right? The quality and the caliber of the people that you employ. And so if you start off with that, boy, you probably have a latency advantage right there.
Interesting. John?
I think, narrow down your strategy and start small. I see a lot of startup firms go a little too broadly or maybe too global, and it's easier to specialize and cut your teeth in one market and one asset class, one set of algorithms, and not to go too broadly and maybe not try algorithm or arbitrage, strategies between markets.
Sure.
And things. So I think start small is key, and focus.
Rob, what do you think?
I think the classical solution to this problem is to first buy it in for the time to market advantage, and then figure out if it makes sense to take. Obviously, when you buy it in, you lose control of it to a certain extent. If you've got a very nimble supplier who can turn on a dime and deliver you bug fixes and new features whenever you ask for them, and they're cost effective and you're happy, then great. But a lot of firms then decide, once they've bought this thing in and got the time to market, it's time to start chipping away at that third-party solution with an in-house solution. So my advice would be buy it in first and make sure that the vendor you choose is in step one is a guy with decent cancellation terms, so you're not paying for it twice.
Well, thank you for answering these questions. If you don't mind, I'm going to turn this over to the audience and open it up for questions. And there's a microphone available there.
I have lots of questions because I wrote the book.
How do you think with the high-speed tweets coming in where they announce earnings and different events, economic stuff, that's going to affect it?
Who was that to? I'm sorry, could you repeat it, Stephanie?
Yeah, how is tweeting going to affect when different earnings or numbers or different events or economic stuff comes out over a tweet, how much more faster is that going to make things happen?
Perhaps what he might be also referring to is how is social media overall going to transform the way we look at trading, perhaps?
Well, if you didn't think that I didn't go and look and see where Twitter, the data center was after that last incident and look to connect that to NYSE or to NASDAQ. I certainly did, right? And the problem is that they're decentralized. Sort of wherever the news is originated, then they emanate that out of the local data center that they're in. And so ultimately, the biggest problem is that if you implemented some sort of, regulatory or confirmation check on the veracity of a Twitter feed, boy, what happens when the next social media site pops up and people start using that for the dissemination of information? It's almost uncontrollable. That's the problem with it. But if you're going to use that to make trading decisions off of, well, then you have to be aware of that risk as well.
It's an interesting one to me because the problem with tweets, unlike, for example, officially sanctioned news releases, they never follow, they're in natural language. You've got to parse this thing, and if you're going to put $1 million behind it, you better make damn sure that your parsing is good. I think it's pretty good for kind of market sentiment. I'm not sure I'd put a tick to trade and $1 million behind it, unless you're really good at AI.
Probably have a good complex event processing engine between the market and
There
that
was
social
a,
media feeds, so you can filter them and cross-check.
A Twitter-based hedge fund out of New York. They don't exist anymore, and that was prior to the last event that just happened. But that was their whole go-to-market strategy. That's how they got all their assets under management. Was we're going to trade market sentiment off Twitter, and they lasted 11 months, something like that.
I think you have your answer there. Anybody else? Okay.
Hi, thanks. Zahn. This is in regards to, exchanges essentially becoming, technology providers, i.e. CME building their data center and Aurora, NASDAQ building data centers. I guess, John and Mike, how do you feel, or where do you feel that trend's going? How do you feel that's going to affect your business? Obviously, with Direct Connects, a trading firm's going to be want to be in CME or that exchange. How do you see that trend going and your business is being affected by that?
That's a great question. There's several exchanges that have built their own data centers, and they're essentially trying to create those communities inside the four walls of their own data center. And I think a lot of that was driven by the merger and acquisition activity. So CME, you look at New York Stock Exchange, they've got to put 3, 4, 5 different exchange properties together. They've got to standardize the technology. They've typically got to pull that out of 3 or 4 disparate data centers and move it into a central site. So I thought it was going to be all the rage a couple of years ago, but I don't think it's panning out very well. We've spoken to exchanges that have data centers in Europe and in Asia and in the Americas, and I think the take-up rate is not very high. So I don't think you're going to see that trend become stronger. It's very expensive to get into the data center business. It's going to cost you $200 to $400 million, to build a reasonable facility, and I think that money is better spent elsewhere. So we went from 0, exchange access nodes or matching engines in Equinix to 115, and I think that speaks volumes about what the trend will look like. I think the exchanges will move into where the communities exist. It's going to be hard to pull those communities out into exchange data centers. But I work for a data center company.
Yeah.
So I would agree,
I'm a little
slanted. Especially with deregulation, allowing any old upstart to form an exchange, and those guys ain't going to build a 200 million data center. They're going to hire some space off, frankly, Equinix, Savis, where customers already are, and I think that's probably the trend. And the biggest problem, I guess, is the exchanges seeing fees dropping, having to diversify into other technology to try and recover some lost profit, and building 400 million data centers and charging astronomical fees for renting space in those data centers. So it's probably going to go back to where the customers are. The other way.
Bernard, you were going to say?
So clearly exchanges have a competitive advantage, right? Because their members have to be co-located with them. That you have a competitive advantage doesn't mean that you have to venture into this business, right? So as said, it's a very capital-intensive business. So you need a lot of expertise to start doing this. And what is very important, an exchange that does that needs to earn that money back. And I think with Equinix we've got a good solution to this, there's this great advantage of working together with Equinix, and it is that the fees are so affordable that there's a whole community in there, not just the people that can pay the really high prices that you would pay elsewhere, where the data center is owned by the exchange.
Yeah. I mean, one, I feel that you're going to see some of the data centers that were built in the last half decade get divested. You know, so that's echoes some of the things that you know, has been said here. Some of the ones that were built by the exchanges proper, they may come on the marketplace, and that's an opportunity for, you know, the Equinixes of the world to make them a, you know, sort of a non-exclusive data center. But also, the way we look at it as an opportunity, then, I need to make the exchange one of our clients. Right, you know, that's how we approach it. Is we say, okay, you know, if they're going to come into our space and serve our customers, then we have to develop a service that that they can consume as well. You know, so it adds another layer to what we're doing.
Thank you.
Others, questions? This one, right?
Hi, I'm wondering, I'm thinking about things in a different perspective. From an energy cost perspective, that's a tremendous balance sheet issue, and I'm just wondering from your perspective what you guys are doing on the energy front to lower costs there, or if it's even an issue at all.
I'm assuming that's for me.
I'm looking at
Not
you.
for me. There's a good anecdote you just told me about Amsterdam.
Yeah, well, I think you know, being efficient is always a major driver. I was just talking about one of our newest sites uses water from an underwater lake to cool the facility, you know, to keep prices down. It's green. The data center basically takes the heat generated from inside the site and heats a college that's adjacent, so it provides hot water for a college nearby. And so things like that are techniques that can be done to keep prices down and make sites more efficient. Power costs vary tremendously by market, and that's typically in a pass-through type model. For our customers, we've got protection built in. If prices go up, we can raise the price, and we don't really see power prices going down. But what you see is the equipment becoming far more efficient. If you look at Intel, if you look at AMD, you know, if you look at the storage array manufacturers, they're getting more and more powerful, but their power requirements are going lower and lower and lower. So that's typically where you realize the cost savings. If you need too much power for your infrastructure, you might need to upgrade and get more efficient, you know, equipment. That's the way you lower your cost. Did that answer your question?
I have two questions. First off, Mike, maybe you can answer this question. It's kind of an anachronistic question, but in today's electronic trading world, is there still room for a point-and-click trader? Okay. And then the second question is, I keep hearing more and more about driverless cars, and which one of you will be an early adopter of a driverless car?
Yeah, so commenting on the first one, I'll tell you that one of our lines connects the CME to ICE, so Aurora to 350 Cermak, and the very first person to buy that was a point-and-click shop out of Europe. And so they're still using an ISV in the standard vein, you know, that we think about 10 years ago. And they are profiting, as much as I can tell, right? And they don't share hardly anything with me. But their statement to me is, we are very, very happy when your line is up and very, very angry when it is down. You know, and so So I think that speaks to the fact that, you know, you don't have to be black box, and it, you know, that their sort of human speed is carrying the day, at least as it pertains to their trade. So I found that very interesting. And then a driverless car, boy, that scares me. You know, we see a lot of people do, you know, at least having traffic cops. You know, you may let it run unattended, but you better have somebody keep an eye on it in case it goes sideways. So, but then again, I'm not a trader. That's just kind of what I've seen in practice.
So he should take that.
Yeah,
He used to work for Google, so I think he should take
Wouldn't you
the,
much rather
driverless
invest
car.
in teleportation or something? I mean, why waste time?
In terms of point-and-click trading, certainly our biggest customers, they're pretty diversified. They've got some HFT interest and some, as I say, yeah, point-and-click trading, and yeah, they're doing pretty well. I think if you've got an intelligent enough model that's clever in terms of assessing fair value, you don't necessarily need a black box algorithm. It's a different style of trading. I always see a spectrum from the really, really fast but reasonably simple algorithm to the doesn't need to be as fast, but reasonably more quantitative, smart algorithm. And yeah, there's still a few click trading houses doing pretty well at the lower end of the spectrum.
And you know this, John, but I think a lot of companies think low latency and high frequency are the same, and it's not. You know, high frequency trading is how long you own or control an asset, and if you're turning it over every second, you can be low frequency, but use very low latency technology. So you can be a long only fund with very low turnover in your portfolio, but you're taking advantage of low latency. So I don't think that low latency or high speed technology is just for high turnover, high frequency type trading strategies. Not anymore.
So maybe I can add something to this. Our team does not only do research on performance data, but also on functional data. So we look at the market structure, who trades with whom, do high frequency traders still stay in the market if there's a crash, for instance. And one of the other things which is interesting, and exactly what you asked, we find that there is definitely room for point-and-click traders. We see once in a while that a big portion of turnover actually comes from those participants. So at least at Eurex, I'm sure there is, yeah.
And if you look at the banks, I mean, by and large, you know, their desks are still point and click. I mean, you know, think about how many screens TT still has deployed, and so there's clearly a marketplace for that for the point and click trader.
Other questions?
Then we'd like to thank you all for attending, and we encourage you to stay around for our networking reception afterwards.
Good job.
Thank you very much.
Of course.